All right. Greetings, everyone. So what we are going to be looking at today, basically, we are going to be understanding the basic uh, quantitative aspects of chemistry, right? So what we are going to be looking at today, basically, is we are going to be understanding what is stoichiometry and some of the necessary calculations involved when it comes to stoichiometry, and also some of the things that we need to know there, right? Now, firstly, to begin with, now stoichiometry, can be understood as a study of quantitative composition of chemical substance and, the qualitative change taking place during a chemical reaction, right? So now, basically, which means what stoichiometry looks at basically is it looks at two branches. It looks at the quantitative aspect, And what is quantitative aspect? Now, basically, now it is all the things that can be measured, right? So within your reaction, all the things that can be measured, right? All the things that can be measured, right? And also what it also looks at, basically, it also looks at now your qualitative. And yes, qualitative is basically what you are thinking of. Qualitative. Let's fix that. It's going to be qualitative, right? So basically now the qualitative aspect is going to be the one now that can be observed. So now there it looks at the things that can be observed. Now, e.g., so now things that can be observed, for example, can be things that can be seen, right? Within a reaction, it can be smelled, right? So for example, now if you are doing a reaction, now you are when you are doing the qualitative, that's where you are looking at things such as your color change, right? Things such as your color change. Now, whereas now here in quantitative, here you are referring things that can be calculated, right? So here, those are things that can be calculated. So now what we are going to start with now, we are going to try and understand what is this concept of a mole, right? So we are going to start with the concept of a mole. Now let's start here. Basically, what you need to know is we all know that your atoms and also your molecules and ions are too small to be counted, right? And therefore, since they are too small to be counted, now scientists came up with a way in terms of what can we do to try and count them. Now, for example, if you can just take a teaspoon, let's say you have a teaspoon of your sugar, right? And I say to you now, take that teaspoon of your sugar, please calculate or rather count all the grains of sugar that we have there, right? So basically, you know that it will literally take you almost the entire day or 2 or 3, right? So it's going to be almost impossible, right, for you to calculate, or rather for you to calculate all the grains of sugar that you may find within a teaspoon, right? So now, because there are more particles, and grains of sugar then, so now that's therefore the scientists came and developed this thing which we call a mole altogether. So now what a mole basically help us with is basically, rather than us dealing with all those particles individually, or rather than us dealing with all these particles of your sugar within your teaspoon. Now, basically, what we do here, we are going to deal with a spatial number of particles, right? So now we're going to have what we call our special number that can help to represent that 1 grain of sugar altogether. So now when we come to basically a mole, so which means we are saying now this a special number is going to be now what our mole Altogether. So now this is going to be what we are going to have a mole. For example, let's start here. You know that in shoes, right? In shoes, firstly, let's say you have shoes. Now you have, let's look at the units. Let's say we look at the units, we look at the quantity, we look at the quantity, and let's say we also look at the object counted, right? Objects counted, and see in terms of what can we have now. For example, if we have a pair, you know that as soon as you hear the word pair, what you can think of, you are thinking of two things. You're thinking of two things. And what are those two things? For example, things such as your shoes, right? So you know that your shoes are always in pairs, right? So you know that when you say a pair, you already think of something and which consists of the quantity of two, right? And now again, let's look at another example. Let's say for example, we want to look at eggs, right? So we say probably we have a dozen. Well, let's say we have a dozen. You know already that dozen, it's going to be your 12, right? Dozen represent your 12, and probably your gross represent your 144, right? And what is going to be the object counted in these ones? Now it is going to be your eggs, right? Yes. So now, and now when we are dealing with these, now we say when we have now our mole, which is that special number, the special number of our mole now, it is given by 6,022 times 10 to the power of 23, which means now for one mole, the mole is represented by this number. So, and this one is the one that now help us to count what? To count atoms, to count the molecules, or just to also count other particles that we may have. Altogether, hopefully this makes sense, right? And now then, let's try and dig deeper and understand what is this mole now. So we are saying then now, this mole is basically an SI unit. So it is going to be an SI unit for the amount of substance. Let's try and make a space here. So we are saying now, therefore, our mole, it is our SI unit for the amount of substance. Now, remember where we started? We were talking about sugar, right? So which means this is going to be the special unit to help us to calculate the grains of that particular sugar, right? Now, and we are saying now a mole particles is an amount of what? It is going to be an amount of now let me write this value. So this special value, basically it's same as 602 with 1 2 3 zeros, 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 and 1 2 3 zeros, right? So basically this is now the special number, right? This is the special number that we then use to represent the particles, right? This the number that we use to represent our particles. So, and now if we can now write this in scientific notation, this is now going to be 6,022 times 10 to the power of 23. How to get? Now this is the representation of moles. Right now, then let's come now to the formal definition of mole. Therefore, so we are saying now, mole can therefore be defined. Let's write it here. Hopefully, you can see. So now, mole is therefore going to be defined as a number. So it's going to be defined as a number of particles of atoms of particles now of atoms, right? So this is going to be that in, so basically now this is going to be what in your 12 grams of carbon 12 now, which means in your 12 grams of your carbon 12. So basically, the carbon 12, it is that special value which it was calculated vis-a-vis, so that we had this standardized value now. And now we have a special name which we regard this value as. So this value, we are calling it now, this special value of ours, we are saying this is our Avogadro's number. Now, this is our Avogadro's number. Okay. Now, hopefully, now this concept of a mole will make sense to you. So now when we refer to a mole, basically now we refer to this special number that represent, that represent that 1 grain of your sugar. And now, for example, if I can give you another example, you know that basically there are many grains of sands that are going to be piled on the surface of the earth, and it would at least almost reach our moon, right? That's how many we have the grains of sand within our our earth altogether. Now, so these are going to be, now this is going to be the special number that we then use to understand the concept of a mole.